was your TAs have been doing a very good job, but more of you should be coming to the tutorials because they'll help you. Um, the marks at this week's quiz weren't quite as good as last week's quiz. But before we get to that, this picture here that you see here is my son finishing the 10K in Vancouver. He did it in 45 minutes, which was 5 minutes less than his previous attempt, so he was quite happy. Now to the quiz. So the marks were about, I think, 75, 78, the average. So much less than this, the almost 100 that we got last week. So one important thing is that you make sure you do the problems and attend the tutorials. I think those that haven't done well will do a lot better. The other piece of good news is that I will be dropping the worst question, your worst mark for the quiz. So if this happens to be your worst mark for the year, then it won't count. Okay. So let's go. Let's see what went wrong. So a lot of you picked E as the correct answer. Now, one piece of advice on these ones that have several choices, if you're sure of an answer, then click it, okay? If you're not sure, or very not sure, or mildly not sure, you'd be best not to click another answer, okay? Because if you click just one of two answers, you'll get half a mark. If you click one right answer and one wrong answer, you'll get 0 marks. Okay, so you're better off, if you're not sure, not to click on that answer. So that question. Where's my? There. Word file. Okay. So these are the 2 correct answers. Now, many of you picked this one. Most radioactivity on the side of the column that receives input from the right eye in the left cortex, and less in the right cortex, okay? Now, in all your columns, you have, normally at least, if you don't have amblyopia, as much coming in to the right as you are to the left, independent if you were looking at the left cortex or the right cortex. Okay, so the cortex doesn't matter. It'll be the same for both. So that's why that question was wrong. But maybe some have difficulty thinking, okay, left eye, right cortex, that doesn't sound very good connection. But remember, depending, one eye crosses at the corpus callosum, at least normally, and it'll get there just as strong. The other question, let's back to OWL. So this one most of you got right, and this one, some of you picked 60 E for this one instead of the correct one here. So what's that, question 3? Let's go back to question 3 then. Okay. I forget which one did some of you pick. I forget which was the, what? E. All of the above is not true. Okay. No. This one is true. Now you can see here. So this is the picture that the eye sees. So this part of the picture, and that side, if you work it out, the right eye gets a signal from the left side, so it goes to the right side of the retina, and it comes straight down through the same LGN and to this side of the cortex. The other side sees things on a little bit to the left, a little bit to the right, I should say, and then it goes to the right side of its retina, and it comes again straight down to the left LGN. So these two signals then get together because this side here has to cross at the corpus callosum. Okay, so information from layer 4C passes across. So this simple cell can see binocularly. That's the only way these cells will see binocularly, by having the signal cross at the corpus callosum. And finally, this one is fine. You pick C as a possible answer. A lot of you pick C as a possible answer for this one. And okay. So the question was, suppose you're recording from an unknown neuron in the superficial layer of the posterior V1, okay? Superficial layer that tells you you're going to see simple and complex cells, cells that are like lines. And posterior means you're looking at the foveal region of the cortex. So those are the two important clues here. And C, which some of you picked, is a small bright flashing light over the fovea. That's correct. But a small bright flashing light is not going to be as good at firing these simple and complex cells as a thin line that rotates and lights up those wedges in layers, the superficial layers of the cortex.